Alright, so we have sample problem 12.6. This is a volume to volume ratio. So there's a couple ways we can do this, and I'll show you both. We have the combustion of propane, and they're giving us 0.650 liters of propane, and they're first asking us what volume of oxygen we would need. So the first step is you always make sure that it's balanced. I have 10 oxygens on both sides. I have 3 carbons on both sides, so this is a balanced equation. I always like to rewrite the equation because that way I have a copy that I can alter without messing up the original. Alright, so we always start with a known, and we know that we have 0.65 liters of C3H8 propane. Now, what we're doing here is we're going to go from volume of one gas to a volume of another gas. So we can use the volume ratio similar to the way we use the mole ratio from the equation. Since these are all gases, we can think of it, instead of moles, we can think of 1 liter of C3H8, 5 liters of oxygen, 3 liters of carbon dioxide, and 4 liters of H2O, as long as everything is a gas at STP. So in the equation, or in our problem, we're going to put 1 liter of C3H8 and 5 liters of oxygen. That's it. We've converted from liters of one gas to the liters of the other. We multiply across the top, multiply across the bottom. So we're going to say 0.65 times 5 divided by 1 is 3.25. Okay, so that means we have 3.25 liters of oxygen that are needed to completely combust the 0.65 liters of propane. Alright, so that's the answer to the first part of the problem. Now, while we're here, I want to show you the other way that you could work this out. Alright, so we can say, we start with 0.650 liters of propane, and what we're going to do is we're going to convert those liters of propane to moles of propane. And we know that 1 mole of propane has a volume of 22.4 liters. So we use that as a conversion factor. Okay, that's called the molar volume. Now we're going to use a mole ratio from the equation to convert our moles of propane to moles of oxygen. And then we're going to convert the moles of oxygen to liters of oxygen. Alright, now watch what happens when we start crossing out things that we don't need, or things that cancel. Alright, so our moles of oxygen cancel, our moles of propane cancel, our liters of propane cancel. Oh, but look, the 22.4 also cancels. And so what we're left with is 0.65 times 5 times 1 liter. And all of that's divided by 1. So really what we have is 0.65 liters of propane times 5 liters of oxygen over 1 liter of C3H8. Either way, we get 3.25 liters of oxygen. So these are equivalent methods of solving it given the information in this problem. Alright, so the second part of the problem is what volume of carbon dioxide is produced in the reaction. So if we have 0.650 liters of propane, how much carbon dioxide is produced? Alright, so now we could take the 3.25 liters of oxygen that we just calculated and use a volume ratio And again, 5 liters of oxygen is in the ratio with 3 liters of carbon dioxide. And so we're going to say 3.25 times 5, I'm sorry, 3.25 times 3 divided by 5. And we find out that we're going to have 1.95 liters of carbon dioxide. Okay. Now, we could also have used the information from the original problem to solve the second part. We could say 0.65 liters of propane, and we use the mole ratio of, or I'm sorry, the volume ratio, 1 liter of propane with 3 liters of CO2 on top. And so again, we're multiplying 0.65 times 3, but this time we're dividing by 1. Alright, and so that gives us 1.95 liters of carbon dioxide. And this kind of makes sense, because if we look at the original equation, for every 1 liter of propane, there are 3 liters of carbon dioxide. So it makes sense that the volume of carbon dioxide would be 3 times as much as the original volume of propane. Stay curious, friends.